Hi friends, welcome everyone to my class. In this class, we will understand how to convert decimal number to hexadecimal number. In the last two classes, we have seen how to convert decimal number to binary number and also decimal number to octal number. In all the three methods, decimal to binary, decimal to octal, as well as decimal to hexadecimal conversion, will follow similar method. If the given decimal number contains integral part, it must be converted by using a successive division method, and if it contains fractional part also, it must be converted using successive multiplication method. And we need to identify into which base we need to convert the given decimal number. Here the base of hexadecimal number is 16, so we need to perform successive division with 16 and successive multiplication with 16. Let us convert 2020, so 2020 by using successive division method into hexadecimal number. First you need to divide this with 16. So 16 ones 16, you left with 4, 42. 16 twos 32, and you left with 100, right? So next 100, 16 6 96. So what is the remainder? 100 minus 96 is 4, so you can write 4. Next again divide with this 126 with 16. 16 sevens, 16 sevens is 112. Is it right or not? 16 times 7, 112. In 126, if you subtract 112, you're left with 14. Okay. So instead of writing 14, I can write E. Is it right or not? 7E. Because 14 is equivalent to E, or E is equivalent to 14. Now, as 7 is less than 16, I cannot go further, and in order to write its equivalent hexadecimal number, I need to move in reverse direction. Hence 2020 in decimal representation is equal to 7E4 in hexadecimal representation. 7E4 in hexadecimal representation, right? Next, coming to fractional part, we need to perform successive multiplication method. It is 0.65625. So first you need to multiply that with 16, find its value. So it is 0.65625 into 16 gives you 10.5. 10.5. But here if I want to remove the integral part, I can remove 10. But in place of 10, what I can write in hexadecimal, there will be no 10, and we can write 10 as A, and you left with the 0.5. Multiply this 0.5 with 16, you will get 8.0, and if you write A, you will have 8 separately, you will have 0.0. This 0.0, if you multiply with any number, you will get 0 again. Hence I am stopping here the successive multiplication process. Now I need to move in which direction? In forward direction. So the equivalent hexadecimal number for the decimal number 0.65625, 0.65625 is a decimal number. The equivalent hexadecimal number is 0.A8. Okay, this is the equivalent hexadecimal number. Now combining these two, I will get the equivalent hexadecimal number for the decimal number 2020.65625. 65625 625 is 7E4.A8. Okay. So if you want to verify your answer, you can verify it easily by multiplying 4 with 16 power 0, by multiplying E with 16 power 1, by multiplying 7 with 16 power 2, adding these three together, and A with 16 power minus 1, 8 with 16 power minus 2. By multiplying all these coefficients with the polynomials of 16 and adding them together, you will get this value. You can easily verify it with the help of a calculator. Okay. So this is the first problem which I want to share in this class. Let us go to second problem. So this problem is, we need to convert the decimal number 172.983 into its equivalent hexadecimal number. Let us see. First, this is the integral part. So you need to perform successive division method, and this is the fractional part. You need to perform successive multiplication method. Now let us take 172 separately and divide this with 16, because I need to convert it into hexadecimal number which has base 16. Hence I am dividing it with 16. Now 16 ones are, if you see here, you have 16 tenths. Okay, 16 tenths 160, and you left with 12. 12 is nothing but C. Is it right or not? 12 is nothing but C, and 10 is nothing but A. So instead of writing A, I am writing here, instead of writing 10 here, I am writing A. And A is 10, which is less than 16. So I cannot go further, and I need to move in which direction? Reverse direction. So the equivalent hexadecimal number for the decimal number 172 is AC. AC. This is the equivalent hexadecimal number for the decimal number 172. Next, we need to go for converting the fractional part into its equivalent hexadecimal number. So fractional part is 0.983. So I need to multiply this with 16. So if you multiply 0.983 with 16, you will get 15.728. 15.728. And I need to separate integral part, right? So this integral part is 15. 15 in hexadecimal can be written as f. So I am writing f separately, and you left with the 0.728, and again I am multiplying 0.728 with the 16, and you left with and you will get 11 point. If you multiply 0.728 with 16, you will get 11.648, and I need to separate this integral part which is equal to 11, but in hexadecimal there is no 11. 11 can be written as b, and when I separate b, you left with 0.648, multiply again this with 16, and you will get this value as 10.368. 10.368. But in hexadecimal number there is no 10, hence I can write a here, right? And you left with 0.368 multiplied with 16, you will have 5.888. 5.888. Okay, and you left with you can separate 5. So here I am not getting the converged number, means there is no convergence here, because it is getting repeated and repeated and repeated. It is continuing, so there is nowhere I am getting zero value to stop. So I want to uh, round off this conversion up to 4 digits after the decimal point. Okay, I need that much accuracy, hence I want to stop here. So if you don't want to stop here, you can write 5 here, and you left with the 0.888 into 16, and you will get some value. Separate the integral portion like that. You can continue up to how many digits you want. If it is not converging, you can round it off, or you can stop after 3 to 4 uh, digits from the decimal location. Okay. Now I need to move in which direction? I need to move in this direction. Hence 0.983 in decimal is equivalent to almost, because this is not exact value, this is approximate value, because this multiplication process is not converging anywhere, hence you will get approximate value. So 0. F B A 5 and so on. Okay. Now this is for the fractional part, and this is for the integral part. This is for the integral part, which is 172, and this is for the fractional part, which is 0.983. Now joining these two will get the final equivalent hexadecimal number for the decimal number 172.983, and it is equal to AC point FB A5. Okay, you can write dots, or you can write up to this. Okay, as I want this much accuracy, and I am satisfied with this accuracy, so I am stopping here. So this is the equivalent hexadecimal number. Okay, in this way we can convert a decimal number into hexadecimal number for by uh, taking the help of successive division method for integral part, and successive multiplication method for the fractional part. Okay, I hope you have understood it clearly. So in the next class we'll come with another video. If you really like this video, please share and subscribe to my channel.